Good evening, everyone. We are just waiting for a few more folks to join in and then we can start. Okay. Topic for today is a bit interesting. Building serverless analytics with AWS Athena. I'm sure a lot of you folks would have already heard about this service and one or two use cases you might have considered using it. Okay, and if not, let's go through this together and see how can you utilize this service and what are pros cons of this service, and in what cases you should actually consider using it, right? So let's just wait for a few more minutes for a few people to turn up and then we could start. Okay. Guys, once you logged in, just say hi in the chat so I would know that people are on and we could see them. Meanwhile, I'm gonna go back and set the focus on my presentation so that we can, start with that. Okay, I see a few people watching in. Can you just say hi in the chat so we know who's in, who's not? Okay, let me switch the presentation so that I can share screen, and here we go. Okay. Okay, so pardon me if I'm going bit uh in this mode. Okay, the reason is I'm not having multiple screen setup today, so gonna run with this. Okay, so let's understand serverless analytics with AWS Athena. Okay, I'll start with my introduction. I'm sure a lot of you would know me. My name is Ankit Seth. I'm founder of DataViz, and you can find me on. You'll see my email ID and Twitter. I am also approachable on Twitter. You can DM me for any questions or any queries that you might have. Okay, so to begin, first question that we see is what is Athena, right? What exactly we could do by using AWS Athena as a service, right? So in nutshell, if I say in a very short description, you can simply run an SQL queries on whatever data that you are storing on S3 without managing any infrastructure, and that's where this thing is categorized as a serverless analytics or a serverless service which you could use, because you're not supposed to take care of anything underlying in terms of infrastructure. You don't have to manage any uh, you know any data lakes, or you don't have to manage any servers to query any sort of data set here. Okay, so that's in nutshell what Athena does for you. It's a simple analytical service which would help you to query a structured data set which is available into S3. It's now not limited just to S3. You can connect to other data sets as well, which in coming slides we are going to go through it. Okay, so if I talk about some more details about Athena, right? Understand, so this service got launched in 2016 during reInvent. Okay, that was the first time when AWS introduced this service. Pricing is bit straightforward. You will not be charged for anything that you are storing. Okay, you would be charged based on the data that you are searching. Okay, so for an example, if you're scanning a data set and it has, so your overall data which you're scanning throughout the month, if it reaches to 1 TB of the overall size, okay, it's going to cost you around $5. Okay, there are no charges for DDL statements, like if you are creating, altering, or dropping any table. Okay, if you are managing any partitions, or if there are any queries which got failed, right? So all those aspects will not be considered while you know billing for your usage of the Athena service. Okay, what are the other things that, like in terms of data set, it's suppose CSV, JSON, any columnar data formats, as whether it is Paraquet or Apache ORC, you could use that. Okay, uh, it has a good amount of uptime. Okay, you don't have to worry about an underlying infrastructure. Okay, that's one of the most important aspect of any service that you are seeing here. Okay, when it comes to serverless, ideally what so you'll have to do your business operations without worrying about the underlying infrastructure, and that's where uh, the whole idea of serverless comes from. Okay, disaster recovery, hardware independence, you are not bothered by any of those points, right? So that's in nutshell what Athena helps you with. Okay, today's session is gonna be bit like introductory session with AWS Athena, because Athena could do a lot of different stuff. Okay, I've been recommending Athena to a lot of my customers in terms of passive analytical service. Okay, what I mean by passive analytical service is, see, a lot of time what happens is you always have analytics service or a reporting module within your product that you're building, right? So whenever you have any reporting modules, you always try to fetch that data set directly from your database using an API interface or using JDBC call, different ways to do this, right? But whatever API calls or whatever JDBC calls that you're making, okay, at the end of the day, it's going to have implications on your business services. Okay, reporting as a service is never a business critical service, which means that even if it goes down at times, okay, it shouldn't be an issue for you, right? So when you are putting a reporting load onto your production system, okay, a production database, you could you basically are taking portion out of your business critical service. Okay, now when any reporting module doesn't require you know a live feed of the data, in that case you could use services like Athena, okay, which would help you to set up a data repository in form of an S3 bucket. Okay, it essentially talks about whatever data that you have stored in your database. You move that database overnight onto an S3 bucket in form of CSV, in form of JSON. It's up to you. It has to be a structured form. Okay, once you do that, Athena would help you to query that data set directly from the S3 bucket without even connecting to your live database. Now, what that does is it helps you to move all that reporting load away from your live service, which means you could optimize the usage of your production database. You could transfer that additional load which comes from a reporting module, okay, to your actual business critical services, right? So that's in nutshell, that's one of the main aspect, okay, that I've been recommending to my customers, that whenever you have a service, okay, which is not business essential for you per se, okay, but you are still putting that service to query from your live data set. Okay, in that case, I you should consider using any form of serverless analytics, so that you're offloading your production database to a better served infrastructure. Okay, so let's understand what are different use cases, okay, that we could do with Athena. Okay, and see, Athena is just a query based service, but in terms of use cases, it has a wide variety of things that you could do. Okay, let's go through that one by one. Okay, now query engine for data lake, I just explained to you, right? So what you can do is you are running an RDS instance. Okay, and that RDS instance is been collecting transaction data, sales data. For example, e-commerce, if you're running, you'll have product database and pricing and sales and all that different data sets, right? Now uh, you are anyways going to export that data set to you know your S3 buckets in form of CSV. And what you can do is you can connect uh, your query engine in form of Athena, okay, to that S3 data lake. What will happen in that case is you can query all the data that you need from Athena itself without going to your database. Second is embedded SQL for direct access of data. Okay, in other cases, for example, I'm running a product which is writing in form of JSON, or for example, you're using Firestore. Okay, Firestore has an export process where you can export that data directly to an S3 bucket. Okay, it will store all the documents in form of JSON into S3 bucket. Now, Firestore doesn't have a native, analytical service associated with it, which could help you to, get things moving when it comes to uh, doing business analytics on top of the data that you have, right? Now, with Athena, what you could do is, you could write simple SQL queries. You could create views on your, data that you have stored. Okay, and access the data right away, okay, without doing any operations, without creating a separate database, without creating any sort of mechanism to prepare the data and then fetch the data. There's no requirement as such. With Athena, what you could do is, if the structured database data set is stored in form of S3, in S3 bucket, you can simply go and create a table in Athena and start querying that data set. Querying logs, okay, that's one of the good use cases when it comes to Athena. We usually use for example, if you're using Lambda. Okay, with Lambda you have those CloudWatch logs. Now there are, in CloudWatch logs, you already have an interface like Grafana or anything like that, which can help you to query the logs. But for example, I have a product which writes its own log streams, right? So I'm storing that data set into an S3 bucket in a structured manner, like year, month, date, and all that stuff. What I can do is I can use Athena to query separate specific log items. Okay, I can query the logs as and when I need, based on the different parameters that I know, which usually comes into those logs. Okay, so you could use Athena to query the logs as well. Okay, query database backups, that's one of the really good use cases with Athena. So as I mentioned, you always take backups of your databases. Okay, whenever you're running something on production, you always have retention copies available in form of S3. If you're using RDS, it has a native backup support which goes directly into an S3 bucket. Now, when you're storing that information into S3, okay, what you can do is you could use Athena with an SQL interface to directly query those database backups which are stored in S3 bucket. Okay, time series or geospatial data. So if you have a product, or if you have logging stream, or if you have a product which constantly push time series data into an S3 bucket, what you could do is you could create a query engine on top of that, which would keep on give you the results based on the data which has been stored in S3. Okay, so see, understand one thing. Athena is like one one-time configuration service. For an example, what you need to do is the setup is very simple. You connect your database. Okay, you connect your S3 bucket to Athena. Okay, tell Athena what are the different fields that you have in S3 bucket, whatever data that you have stored, what is the structure of that database. Okay, and once you are done with that, Athena does the rest of the things. Okay, Athena keeps on building the data set in the backend, and whenever you are writing a query, whenever you are invoking Athena with a query, okay, it will go and it will search the data and it will give you the results. Of course, the thing is it's a complete async process. So if you are planning to use this, okay, in form of a synchronous data analytics service, no, it's not going to work completely off the shelf. There are things that you could do, and we had done few implementations which we actually gave the response back, okay, till the time the analytics service Athena is running that query. So I see Vinith is in. Hi Vinith. So so now understand, it's in nutshell, it's very simple and straightforward. Okay, you store something into S3. Okay, you give reference to Athena, and give reference in terms of what kind of a structure it has, whether it's a CSV, TSV, JSON, what kind of a data set is that, and you do the field mapping in form of, like for an example, if you're getting 5 fields in the CSV, okay, these are the 5 field names. The way you create a table in your a normal MySQL database, similarly you'll have to create table in Athena as well. Okay, and once you create that table, Athena would map the actual data set which is there in S3 with the table that you have created in this Athena setup. Once you do that, whenever you write a query, it will go in and fetch the data that you need directly from the S3. Okay, so mind one thing here, that you are not being charged, okay, for any number of tables, any number of partitions that you are creating in Athena. Okay, so for an example, you today you created a table in which you have good amount of data laying and attached with an S3. Okay, but for a year you are not doing any searches, okay, with that data set, you will not be charged anything, although that data is being managed within that Athena table space. Okay, but you will not be charged anything until and unless you query that data set. And the pricing is also based on the similar aspects on what kind of scans, like whenever you are writing a query, what kind of data you are trying to scan here, what's the total size of data that is being scanned. For an example, you created a simple table, it has 10,000 rows. Okay, if you are doing select star from that table, you would be scanning 10,000 rows. In that case, you will be charged for those 10,000 worth of data that you scan. Now, when I do select star from XYZ table name, where ID is equal to 1, for an example. Okay, when executing that query, okay, the data set that it needs to go through, okay, that's something that you will be charged for. Okay, so we'll go through that in a few slides later. We'll have an actual demo that we are going to do with Athena, so that you guys would actually know that, okay, fine, how can you create tables, how can you create how can you write queries, how can you connect an actual S3 bucket with Athena. So there are various things that we are going to do try today. Okay, so that will make things more clear for you. Okay, now other than that, let's understand what are the limitations with Athena. Okay, one thing, it's pricey as in you probably will think that uh, with 1 TB of data scan, it's just costing you $5. It should be a no brainer, it should be good, right? Think from a perspective that you are running a service. For example, you're running an e-commerce service on which you have 1,000 people logging in and fetching various reports. Now, this reports, in nutshell, like, you would have to quantify with the number of users that are walking in and trying to search any kind of a data set from your database. Okay, so for an example, somebody is trying to search anything with respect to product, and with that product, what you have is 15,000, 16,000 rows. Now, every time a reports get executed, you would be seeing a scan of those 15,000 rows. Okay, so it's not when it comes to building a serverless analytics solution, Athena needs to be used very wisely. Okay, there are various use cases which are there. In that, you need to use it. For an example, if you're looking for something which is stream live in the sense that I'm running an analytics, okay, on my product. Again, I'll take the same example of e-commerce website. Okay, if I want to create a data set every hour, it's going to be very pricey, because every hour you are going to run a service which would collect everything and put it up. So you, from operations perspective, you're putting an overhead on this. Okay, on the other hand, if you're looking for something which is synchronous in the sense, okay, that's the second point, the data fetching mechanism with Athena is in async mode, as in, the process is, you would go in, okay, execute a query. Okay, then that query gets into a queue. Once that queue gets once that queue is being invoked, okay, your query would start getting executed. Once the result set is available, then you could try to fetch those results, and that's how you would be able to access the data set. Okay, it's not synchronous, which means that when you make first call, on the same call you will not be responded back with the results. Okay, on the first call, when you initiate a query, okay, it's going to reply back to you with a, a query ID, which is the thing that you need to use to track the execution status of that query. I'm gonna show you some analytics that I have, which one of the customers that's been using Athena with us. So that's one thing. So if you know that you're in a month, you're not going to cross 1 TB, 2 TB of scan, by all means you can use it. And it's one of those services in which without even worrying about the infrastructure, I can simply put it out and ask anybody to use as much as they want. Okay, because what happens is, when you have, for an example, 1,000, 2,000 users querying for reports or querying for any sort of analytics from your product, you would have to optimize your RDS or database to serve that load. Okay, when you move that to AWS Athena, what happens is, you are not worried about any infrastructure when it comes to database. Why? because you're simply storing that into S3. S3 is nothing but an object-based storage. Okay, you're not paying for any infrastructure other than the the amount that you're storing into that particular S3 bucket. That's one thing. Second, you don't have to pay anything to run any infrastructure for querying the data set with AWS Athena, right? So that's when I think these are the cases where AWS Athena comes out very strong. Okay, but as I mentioned, it's a complete async process. So if you're looking for something where somebody would go in, try to search something, and if it needs a result right away, okay, it's going to be difficult. Other strategy that I've been recommending to my customers, see, a lot of time what happens is bigger enterprises would have their own mechanism for hot, warm, and cold buckets, which means that I'm running a product. Uh, you would be able to search any data right away for last 3 months. For example, that's my hot bucket in which I'm storing all the data. Then it comes to warm bucket or cold bucket, which means that you can search the data, but the result might come back to you in form of an email or in terms of notifications. Okay, so what you do is, if you want to search anything which is older than 3 months, okay, you simply shift that data onto your S3 bucket. And once you shift that to an S3 bucket, you can optimize your cost of RDS usage, okay, in terms of storage. That's one thing. Second, what happens is, if somebody wants to search something which is 3 months old, you can take them to an async process. That, okay, fine, if you want to have something which is 6 months, 8 months, 1 year old, what you can do is you can store that data set into S3, connect that to an AWS Athena. Now what you do is, when somebody search for something which is older than 3 months, you simply said, okay, fine, we have taken your request. You will be notified once your report is ready. Once that happens, what it does is, in the backend, okay, you are running that query using Athena. And once the query result is success, once you have searched, once you have the result set ready, you can create a CSV file or an XLS, whatever way you want to generate that data set, and notify the user. Okay, that's the async process that you could do. So these are the cases where you could use Athena very optimum, in a very optimum way. Okay, because it's going to help you to run those queries easily without worrying about infrastructure. At the same time, you don't have to worry about storage, you don't have to worry about and like having something which is not frequently used, right? So if you're putting that up into your RDS itself, you would be paying for the RDS storage. At the same time, you would be paying for the infrastructure as well, because the more data that you need to scan, you need better CPUs, better resources to query that data set, right? So that's one thing. Second thing is, for an example, I have a process where I'm archiving all my data from my mainstream RDS instance to something which is not live. Okay, so I'm archiving all my data into S3 bucket. I'm using S3 as my data lake. Now if somebody comes up and says that I want to see something which is 3 years old, you're not going to put that data set directly available into your RDS. Okay, yes, of course. People have set up data warehousing in that case, but I'm talking about, what if I'm not having a complete data warehouse setup, because those are pricey, again, pricey components, right? So what I could do is, I always take backup of my data, and I keep only last 1 year data as an active on my database, and rest of the data goes into my S3 bucket. In that case, I can use Athena to query that data set. Okay. Third point that I have seen is, altering the data structure post data collection is not feasible. Yes. So for an example, if you created a new table, if you created a new database right now, okay, and if you want to uh, query the database, now today you have three columns. Tomorrow you might go to 5 or 6. In that case, okay, you'll have to delete that table and recreate it. It's not big overhead, but I'm thinking when you have a larger data set with a good amount of partitioning done, yes, that's going to take some time. Okay, so these are some of the limitations that I've seen with Athena. But if you are planning to use something with analytics as a service without creating an underlying infrastructure, Athena is a way to go. Okay, I'm sure. See, a lot of the current products are built using NoSQL or SQL based data sets, right? So you could export that in form of CSV, you could export that in form of JSON, okay, and both of these things are supported in Athena. So ideally you could create your whole reporting interface, okay, using AWS Athena without worrying about any infrastructure or any things whatsoever when it comes to this. Okay, so that's that. Without much of ado, we are going to start with the demo for our setup. Let me check if I can access. Yes, I can access it. Okay, so before going into Athena, what I have done is, if you go to S3, I have set up a small, data set for us. Let me see. Yeah. So in this table, what I've done is in a uh, city, state, country. So that's the standard list that we have. So countries, cities, and states, all these informations I have downloaded that in form of CSV and stored into an S3 bucket. Okay. What I want to do is I want to create a standard query interface using Athena, and we are going to use this all data sets and load that data set into Athena, and then let's query it one by one. Okay, I've already indexed the cities data set because that's something that I was doing for my own querying. So okay, so this is how the interface looks like. Okay, whenever you log in for the first time, you'll see that simple get started column, right? So in my case, I've already started using it, so you will probably not see anything like that. Okay, so in data source, you would always see AWS data catalog, and then under that you will see databases. Now this is different database that I have created. You don't have to worry about putting data here. Okay, it's just the reference that you're doing, so you're not going to get charged for having the databases here. Okay, you could then, whatever database that you're seeing, you would have the same structure that you see in a normal RDS or any standard SQL interface. So you have a database. Under that database you have tables and views, right? Similar things that you will see here as well. Okay, now what I want to do is, okay, so first let's connect to a data source, which actually I have already done, but anyways, let's do it again. Okay, so we'll walk through this process. So where did I go and click? Let me redo that thing. Okay, so first thing that you need to do is you need to connect to a data source. Okay, there are various ways to do it. Same thing what I'm doing from a UI, you could do that from a API interface as well. Okay, so Athena has a complete API interface also available, which would allow you to create data sources, create databases, create tables, execute query, get the query status, and see the result. So all those things you should be able to do it using API interface as well. Now let's click on connect data sources. That's where we are going to see this. Now okay, a lot of you would know AWS Glue. AWS Glue is an ETL service available from AWS again, which would help you to write any crawlers or any kind of collections of data sets. We'll come to that part in the coming slides. But yeah, so see, querying data from S3 or querying data source, which is right now in beta. As I mentioned to you, you could directly connect your MySQL, Redshift, DocumentDB, DynamoDB directly, and use Athena as your service. You could even connect your own data connectors. Okay, for example, something which is not available here, you could use Lambda to create your own connectors and get things moving from there. But right now we are going to simply use S3 as your query engine, as your data lake. Okay, so we are going to query data directly from Amazon S3. We are not going to use Apache Hive or Glue, either of it. For an example, for now we are going to stick with AWS Glue data catalog. Okay, now this is where things gets interesting. So are you going to use Glue to crawl that S3 bucket, retrieve all the data which is there and create its own mapping, or do you want to create an table structure manually? These are the two options that you would see here. Now what does this mean? For example, in S3 you have multiple partition data that you have defined. For example, you have taken data backups on daily basis, right? So you would have created year, month and date structure there, okay, to store all the data set. And if that's the case, you could use Glue to crawl your whole data set and retrieve the schema which is required. On other aspect, what we could do is we could enter this information manually as well. So in our use case right now, what we are going to do is we already have countries CSV file available into S3. What I'm going to do is I'm going to add fields manually here. Okay, and then those fields, using that fields, we are going to create a table, and then we are going to scan that data set. So we'll use this option because we are going to add the details manually. It's not a big data set, so it shouldn't be an issue. Okay, now next up is, do we want to create any database? We don't want to create a database because I've already done that. Okay, we could create, yeah, you could create a new database, just write the name here, shouldn't be an issue. Okay, so what should I do? I should name it as countries. Okay, now here is the main thing: location of input data set. Now there are multiple ways you could give reference to that data set. Now understand one thing: Athena supports partitioning as well, which means if you have created, for example, loggers, right? So in logs you would ideally separate your logs in form of year, month and date. So you have daily logs available in under S3 bucket. What you could do is, if you see, there are references given here as well. Okay, so if you have something in which you want to create partitioning manually, okay, so if you're using Glue, it's gonna scan the whole schema and it's gonna tell you that this is the schema that I think you are trying to achieve. If that works for you, you can accept and then go forward. But in our case, we are going to do that manually. Okay, so still in our in present scenario, we don't have any partitioning or any structure available. It's a simple CSV file which we want to load into Athena and try to query, right? So in our case, we could actually go with a simple folder like this. But if you have a structured data set, right, so you have S3 input data set logs, and this is the partitioning way: year, month, day, if you have YMD format defined, right? And then you can just input the base location. So in our case, what we are going to do is, let me take the name again, city sample Athena. What we are going to do is we are going to do this. Okay. Yeah, another thing. Do you want to encrypt the data set? Okay, so if you want to encrypt the data set, you can encrypt it from here as well. If you are using encryption in S3, if you have enabled there, that's also going to work. Okay, now these are the different formats that Athena supports. You could do Apache Weblog, CSV, TSV. If you have a text file with custom delimiters, in that case it's going to ask you what delimiter we want to use. Okay, so in I don't know, maybe an MD format or any other format that you might want to use. Okay, in our case, it's a simple CSV file, so it shouldn't be an issue. Okay, now since we selected that we want to map everything manually, that's the UI that you're going to do. Now I have names, sorry, country name string. Now we have ISO2, that's again string. Then ISO3, we have it as string. Add a column. Let's do country code string. We have another called continent code. That's also available as a string. And then there is create at. It's a timestamp. So let's do timestamp and update at. I'm not sure if this is exactly the timestamp format that generalized available. Okay, but yeah, we are going to give it a try. And if you want to do bulk add columns, you could do that as well. In our case, it's not a big data set that we are going to try, right? So let's do this. Now, this is where you're going to create or configure any partitions that you might have. Okay. So see, ideally, when you have created your own data lakes, it's ideal if you have a partitioning strategy to, you know, index, like to search the data in an optimum way. Okay, so for an example, if you are running a reporting service on top of your analytics platform, you don't want to scan the whole data set because it's going to be pricey, right? So in that case, you could create partitions, okay, based on year, month, date, whatever strategy works out for you. Okay, and based on that, you create a partition and then let them scan the data based on the inputs that are coming in. So it's not going to scan the whole data set that you have, since it knows what partition to go to when you're trying to search for a specific data set. Okay, so I'm going to create table. I hope it's going to work. Okay, so query is successful here. Okay, and let's see. Okay, so countries table is already available here. We are not sure whether, okay, so now what we have done is we have created the table. We don't know whether the data is there or not. Okay, so this is simple. Like if you see the query, it's a simple create table query with a location given to an S3 bucket. So we are not out of the loop yet. Like, we don't know whether we could scan the data, the mapping is correctly done or not. Only thing that we know is we have created a table with a reference to this S3 bucket. Let's see what happens. Okay, now if you see here, you would be able to see all the things that we have done. Now let's do, okay, so I had already queried the data for cities. Okay, if you see, we have all the data that we need. Okay, mind you, one thing, yeah, that's one thing that I missed in this time as well, but that's okay. Let's do countries and then I'm going to show what I meant. Let's not do any order ID or anything. Select star from countries. Sorry, so if I write, let's see if the data is in. Data is in. Okay, good to hear that. Created at, updated at didn't came. I think that's because the format didn't match. Okay, bear with me for that, but we don't need that information anyways. One thing that you need to do is you need to remove the headers from your CSV files. Make sure of that, otherwise it's gonna look something like this. Okay, so we have all the data set that we need from here. Now you could do whatever you want. For an example, select star from cities that I have. Okay, and what I want to do is I want to do select name ID, state ID. Okay, this is what we are going to take. Okay, let's do country code as well. Country code from cities. Okay, so this is available now. What I want to do is I want to bring select star from countries. Let's do this. And here also you will have a country code. You see this ISO2, that's the 2-letter countries code that we have seen here. Okay, now what I want to do is I want to merge and query both the tables together. That something is also possible the same way you usually do it with, I hope I know what I'm doing, but let me try. Cities.id, cities.state id. Now I'm going to do country dot, okay, what is the field name? Country name. Okay, country dot country name. Am I doing it correctly? I think so. From cities and country. Sorry, I think I did one mistake. It should be countries. From cities and countries where cities dot country code is equal to countries dot, we have it in ISO2. So let's do ISO2. I hope it works. Let's see. Yep, it works. Okay, so now in this case, what you see is, so we have taken city name from cities table. ID is also coming from cities. State is also coming from state. Now country name is coming from the countries table. Okay, let's do, and countries.iso2 is equal to IM. Let's search something for India, right? Oh, what mistake did I do? Did I miss anything? Yeah. So I just forgot to put a quote there. Okay, so countries are coming properly. Now let's do one thing. We still don't have state name here, right? So let's do another, data source addition here. Okay, let's import the state data set as well. And for that, I'll have to check the data set. So just bear with me for a second. Let's do states. Let's do s3 colon double slash. What's the name? City sample Athena. Okay. I'm going, oh, sorry, I forgot slash here. That's why it's telling me don't do that. We'll use CSV. Okay, just give me a sec. I'll have to open the data set because I don't know the structure of states. So just bear with me for a minute. I have the state CSV here. Okay, so it is ID name. Okay, let's do this. So we have ID again, then we have name. So that's again string. Then what do I have? Country ID. Oops, country ID. It's again, it's not a string, but it's okay for now. Country code and state code. Okay, country code, string, state code, string. Am I missing anything else? No. Okay. So these are all the columns which are there. We are not going to do any partitioning right now. Let's see. Okay, query successful. We'll see states as well here. So let's try to, okay, close the things that we don't need. So I think we have, okay, let me use this one. Let's do select star from states. Let's see if the data is in or not. Yep, the data is in. Now what I want to do is, okay, let's create, let's take something else. Okay, we do select star from cities again. Okay, what we were missing was state name, right? So you have id, don't mind this anyways. Okay, I skipped something in that, but okay, order by id, let's do order by id. Things should be good. That's what I thought. Okay, now we have state id and state code in it. Okay, so let's do based on state code. So we are going to bring state start. What is the name for state is? Okay, I think I miscalculated the position of the data, and that's why the columns have been switched. But nonetheless, we should be able to take care of stuff. So under country ID, we actually have state code. Okay, that's going to be a messy stuff. No, there's something wrong because under states we are still seeing, I think these are country names. That's strange. Okay, I'll not dig through that further. But what I wanted to showcase is I wanted you guys to see that you can create, you know, a structured views in this thing as well. So for example, if you have multiple tables that you have done and if you want to store that in form of a view, right, what you can do is let's do city view, and then let's, oops, where did my query go? Whoa, whoa, whoa. Okay, I'll have to write it again. Select star from cities, order by ID. Hmm. Hmm. So now what I want to do is I want to do cities dot name, cities dot uh, let's do city name and simple country name. That's it. Countries dot, and what do we have in countries? Let's try that stuff. What do we have in countries? It's, I think, country name. Yeah, country name. Country name from cities and countries where you have cities dot country code is equal to countries dot ISO2. Let's see. Okay, so we have city's name, and let's do as well. City name, country name as country name. Okay, so if we do that, it should give us the query. Yep, so we have city name with country name mapping up with this thing. So what I want to do is I want to turn this thing into a view. Okay, let's create a view. So now you would see city view. Okay, a view is already been created. Now rather than writing this query, let's do select star from city underscore view. Okay, yep, there you go. Okay, so see, things are much easier in terms of interface with Athena. If you know a normal, SQL interface, how do you need to create different tables, if you know what kind of fields that you want to use, if you know a simple SQL interface, SQL language, right? You should be able to query data very easily using Athena. And the good part about this setup is, for example, I've created something today, right? So until unless I'm using this to scan my data set, it's not going to get me anything on my monthly billing. Okay, that's something that you should consider. If you're running a product in which you want to have some stats which you don't want to openly available to a lot of different audience, you could use this, and that's going to help you to get the analysis that you're looking at. You can create the views by connecting multiple tables or multiple data set that you have. Okay, so that's it from my side with Athena. Okay, there are a lot many other things that you could do. The next stage probably would be to understand how we could do partition in it. How can you know query the different data set using it? How can you update the data set? So I'm going to walk you through one small thing before we close this up. I'm going to remove this and I'm going to add another page for you guys to see. Share my screen. Let's do a Chrome tab, function details. Okay, I'm sure all of you guys should be able to see what is there on the screen. Okay, let me just put it up here. So what I have done in this thing is, so I have a report, okay, which is running on Lambda. Okay, what I'm doing in this thing is, we have created a data pipeline which is pulling all the data daily once from your active database to an S3 bucket. Now, the pain that customer was going through is that whenever he wants to scan, whenever he wants to search any data set which is of last 1 year, last 2 years, they were having issues. Okay, not just last 1 year, I'm saying last 2 months even, because the number of transactions are very huge. Now, in this case, what did we do is we created a simple API interface, okay, which allows you to query the data set. We use Lambda to write our own SQL query. Okay, same query that you've seen here, right? Now, that query initiates a request to Athena. Okay, so the data is stored in S3 bucket where in form of CSV. Okay, now this execute query invokes a Athena, and then what we do is, mind you, this is a complete async process that we have set up. Now what this lambda function does here is, between Athena, this lambda function keeps on trying to check the state of that service. So service request Athena, what it does, it keeps on trying to know the status of the query which it invoked. Okay, once the execution comes back with a result set, okay, we start writing that data set in form of an XLS or CSV file, and we put it up in S3, and then we use you know a post call, okay, to notify the user, okay, that this request has been done. You can fetch the data set and you can view the data that you are looking for. What are the challenges that we had faced? Okay, so in this setup that you see, one of the main problem is, when you are running data collection over an API interface, there is a limitation with Athena that APIs will not allow you to have more than 1,000 records in one request. So if you are trying to scan something which would return more than 1,000 records, you need to have an interface, you need to have a mechanism in place which is going to, you know, query the data set one by one in form of a pagination method. Okay, so be ready for that. If you are, see, in my case, we wanted to write all the data in form of xls file and then wanted to give it to customer. Okay, so if you are putting that up in form of table view or anything for a front end, it's good. Not an issue there, because you could do that pagination logic there. But if you're running something like us, in which you want to generate the whole data set in form of xls or csv, in that case you need to have a mechanism which would do a loop call. It keeps on taking data again and again from Athena, and then write all the data together in form of xls file or csv file and then give it to customer. Okay, so that's the thing that I have. Okay, and that's all I wanted to share today. Thanks a lot everybody to tuning in. Okay, I'm sure it's difficult, but things are improving day by day with the COVID stuff. So hope to see you soon. Hope to see you soon in face to face discussions, face to face meetups. But until then, we are going live with the setup that we have. Okay, so tune in again next Saturday. We have another awesome speaker coming in, who's going to talk about again serverless platform that he built. And of course, the serverless days that you were seeing were actually hosted on their ticketing platform. So he's going to talk all about what, like, how he built the whole ticketing platform on serverless with almost zero cost. Okay, so thanks a lot for tuning in today. Bye bye.